Again, double angle identities. Hey, this is a fun topic, fun things, not too difficult, not too bad. One of the reasons maybe we use double angles way back when in our textbooks, we used to have to think about, we used to find different sine and cosines of different angles. We had tables that we'd have to look up, and we'd have to look them up and come up with all the decimals. And the way that they did that is by using these different identities for sine and cosine. Luckily for us nowadays, we don't have to do that. We actually have identities that we can use and that are here for us. So we're going to go ahead and talk about this. We've already discussed how the sum and difference identities look like this. Sine of A plus B is sine A cosine B plus sine B cosine A. And the cosine of A plus B is cosine A cosine B minus sine A sine B. Or if we have the difference of sine, we have sine A minus B is sine A cosine B minus sine B cosine A. And the cosine of A minus B is the cosine of A cosine of B plus sine of A sine of B. This right here is going to be very beneficial as we look to do our double angle identities. So here up at the top, we kind of are assuming that A and B are different angles. The question is, what if they were the exact same angle? Well, then we would then write it more like this, written right here, sine theta plus theta, which would be the sine of 2 theta. And now let's apply that to what we have right here. So if we have sine of an angle plus an angle, that's sine of the first angle times the cosine of that first angle plus sine of the second angle, which again happens to be theta, times the cosine of that first angle, which again is also theta. If you look here, what are these two things right here? I'm hoping you said they're exactly the same, because they are exactly the same, which means if I have one of them plus another one, that gives me 2 of them. That's 2 sine theta cosine theta. So the double angle for sine of 2 theta is the sine of 2 theta equals 2 sine theta cosine theta. If you look at cosine of A plus B, again remembering our sum identity up here, cosine of A is cosine of A cosine of B minus sine A sine B. What if A and B were exactly the same angle? In other words, what if A was theta and B was theta? Theta plus theta is 2 theta, so we get cosine of 2 theta equals cosine of the first, which is cosine of theta, times cosine of the second, which is also theta, minus sine of the first, which is theta, times sine of the second, which is also theta. Okay, we saw this at the very beginning of this unit. Cosine of theta times cosine of theta, we call that cosine squared theta, minus sine theta times sine theta is sine squared theta, and that right there is the double angle identity for cosine of theta. Cosine of 2 theta equals cosine squared theta minus sine squared theta. Now, with cosine of 2 theta, there's actually, by using Pythagorean identity that we all know and remember, which is sine squared theta plus cosine squared theta equals 1, we can actually come up with 2 more equations for cosine of 2 theta. If we replace cosine squared theta, so down here on our Pythagorean identity, if we were to solve this for cosine squared theta, we would subtract sine squared theta over, and we get that cosine squared theta equals 1 minus sine squared theta. So if I actually put this into this equation for cosine squared theta, I get that the cosine of 2 theta, by the way, please notice, cosine squared and cosine of 2 theta, totally different. Squared here is our little exponent for cosine squared. Here, cosine of 2 is a big, theta, equals, and I get that from right here, cosine of 2 theta equals, I now just substitute 1 minus sine squared in right there for cosine squared, so that gives us 1 minus sine squared theta minus sine squared theta. which, if I have a minus sine squared theta and a minus sine squared theta, that's a minus 2 sine squared theta. So cosine of 2 theta also equals 1 minus sine squared, or 2 sine squared theta. By the same vein, instead of solving for cosine squared theta, if I actually now solve for sine squared theta, I would get that cosine squared theta equals 1 minus sine squared theta. I then can substitute 1 minus sine squared theta up into this equation right up here for sine squared, giving me that the cosine of 2 theta equals cosine squared theta. Sorry. I showed you where I was subbing that in for. So we already solved for cosine squared theta. I'm so sorry. See, I even make mistakes sometimes. Don't worry, we're going to solve this for sine squared theta. That's going to be 1 minus cosine squared theta. That's what we want to solve. That's what we want to substitute in for sine squared theta right there, giving us cosine squared theta minus parentheses 1 minus cosine squared theta. Distributing the negative, that then equals cosine squared theta minus 1 plus cosine squared theta, which therefore it follows that cosine of 2 theta will equal 1, 2 cosine squared theta minus 1. And that is our third part of the double angle for cosine 2 theta. All right, that's that video, and we'll come back next time in just a minute.
Did you do both?
Oh, I did. Oh.
There's supposed to be one on there.
I'm going to do one on there.
Like
Oh,
they were
oops.
supposed to do the